I need to interrupt this video because it's way too easy on YouTube to make the build processes of projects like these look way too easy. Just cut a few clips together, put some music over it, and it looks easy peasy. But this has taken me so long, and I just want to run through why, really. Well, 5 months ago, when I uploaded the first electric bike video, I kind of felt like I rushed that video because I spent so long trying to get the bike working. I just kind of had enough and just put the video together, you know, quite quickly. And it really didn't convey the difficulties that I ran into. The motor mount and pulley and actual motor setup in the first original video looked like I just picked them out of a hat, but in fact that was the version 3 motor mount, and I'd also changed motor and also changed the speed controller. So the cost involved behind the scenes, which obviously you didn't see in the video, was quite high. Originally I used a 50 amp speed controller from Hobby King, which cost me about £40. It's just made for model cars, and it worked alright, but the trouble is I kept having the motor stalling, which I think I mentioned in the Q&A video. I have to limit these motors to about 50 or 60 amps or they start to stall. So first of all, I wasted the money on that first speed controller. Then I invested in a VESC or a VESC, and that worked pretty well. It worked flawlessly pretty much, obviously once the current was limited. Then my job was to make the bracket and the motor mount and the pulley all work a lot better. And it was actually working really well in that video. The only frustrating thing is that because I rushed the video, I didn't get much time to convey how fast the bike was, which is why I made that speed testing video afterwards. Now, even after that, I still felt like it didn't really convey the actual power of it. Most of the people, when you watch it on video, you just have no idea, and it looks quite slow. It looks like you can pedal quicker. But whenever I let my friends ride on it, they were all really impressed with the power. So, you know, I guess the next step was to increase the power and see if it looked any quicker on video. Now, the VESCs or the VESCs are specified to take up to 12S lithium polymer batteries, which is about 50 volts. In the video, I was running it at 6 cell in the original video, and I upped it to 10 cell batteries. Unfortunately, I did try it on 12 cell, and it did kill the VESC. I know they're rated to 12 cell, but for some reason it died. So I thought, oh, that might be a dodgy VESC. I got it replaced. And then what I also thought is I would change the gear ratio, because on 12S I think it would have reached like 40 miles an hour on a single motor. So I thought I would change the gear ratio and reduce it down to about 30 miles an hour or 25 miles an hour and just have more acceleration torque. So back then I didn't have the Creality CR10 large print volume 3D printer. I still had my Costal Mini, which is a very small print bed size. So I actually had to print the pulley in 8 pieces instead of the original 4 pieces in the first video. So this setup on 12S did actually work for about 1.5 miles. About 1.5 miles down the road, the second VESC died. I know they're rated for 12 cell, but I think it's something to do with the controller chip, a DRV error or DVR error or something like that, and it just kills the VESC. So I thought, to be safe, I'll settle for 8 cell batteries, because the VESC still gets quite warm on that, but it's still well below the voltage limit. I then thought, why don't I invest in a higher kV motor and keep the 12 cell gear ratio and see if the torque is slightly more than the old gear ratio in the video I uploaded about 5 months ago. So I stopped using the 149 kV motor and I bought the 192 kV motor from Hobby King. It's the same size motor, just different kV, and then running it on 8 cell with the gear ratio of, I think it's a 12 tooth pulley on the motor and 184 tooth pulley on the wheel, which is the same one here. And that worked really well. I could actually up the current flow a little bit because the way that the VESC controls the motor is it sends pulses to the motor and it also receives a backwards current, so it can detect where the motor is and sort of it's a bit too complicated to explain, but it sort of reduces the stalling. So basically, brushless motors like to spin fast. They perform a lot better at higher RPMs. So to have a higher RPM spinning motor and then geared down to the back wheel, theoretically should have been better. I kept this 192 kV motor setup, single motor setup with the larger pulley on for about 2 months or so. It was working really sweet. I was getting good range, good performance, pretty happy with it. And then I took it to a drone racing event, and on the way back I was very lazy and left it in the car for about 2 or 3 days in mid-summer. Now in England it doesn't get as hot as it can do in some places, but it was enough to warp all of the PLA parts. It was all printed in black, and when I reached into the car I touched the frame and the frame was really hot, so obviously it all conducted into the PLA. The whole pulley was all warped. The motor mount, the clamping force had completely gone because it had just warped out. And yeah, so instead of reprinting everything, I thought why not upgrade once more time and go to a dual motor setup. And this is what you can see behind me. I'm not going to make this sound simple again because this is actually the second version. I didn't make a video of the first version because it didn't work, and I'm just going to run you through that now. So the first version of the dual motor setup, each motor had a pulley which would drive the belt, and then it was mounted on the top here. I should put a picture just here actually, it might be easy to explain. So the issue I had with the version 1 dual motor setup was driving one belt via 2 motor pulleys, and I should have foreseen this, and looking back on it, it makes complete sense. But basically, when the belt goes up towards the first drive pulley, it's under a lot of tension because it's pulling, the motor is pulling the back wheel around. So it's on really high tension. As it goes over that first motor pulley, the tension is a lot looser, a lot less. So this becomes an issue when it goes back up to the second motor pulley. It's on really low tension, and it causes the second motor pulley to slip and skip along the belt. So it basically renders the second motor useless. Which, looking back on it now, makes so much sense, but at the time I had no idea that it was going to happen like that. So the only way I could fix this was to go to a single drive pulley, but still use 2 motors, and this was the method that I came up with, and I'm just going to pick up the camera and run you through the final setup. So here is the final version of the dual motor setup. As you can see, here is a 184 tooth pulley on the rear of the wheel, on the rear wheel, and it's all printed in one piece actually, because I can now print on the Creality, which has a huge build volume, which is very handy because it increases the strength a lot. It's cable tied in 8 places, 16 places. Yeah, I can't be able to count it right now. A lot of places, and then has a, I think it's a 1.1 meter long timing belt, 15 millimeters wide, and a HTD5 pitch tooth setup. So it's the same belt, just slightly longer as the previous version. Now here's the interesting part. The drive pulley is just here. Essentially, if you remove that, it is the version 1, the single motor mount. On the other side, it's slightly different, but it's basically the same. There's the bearing to keep the belt tight against the pulley and stop it from skipping. So this is what I've had to come up with to drive a single belt via a single drive pulley from 2 motors. Essentially, the motors are just linked by a pulley, by 2 pulleys, which bolt onto the ends of the motor can. On the first version e-bike, I had I had a fan on the motor here, and I just replaced the fan with a drive pulley, which would then drive this pulley. Now this is actually the second version of this pulley. The first version was slightly too small, because what's interesting is these motors have a fixed distance. So to tension this pulley, the only way to tension it, or release the tension, is to either print larger or smaller pulleys, which takes a lot of time of printing, but it's the only solution I could come up with. I did quite a lot of calculations to try and get them right first time. Unfortunately, I got it right second time. The first time was just slightly too loose, and it would skip on full throttle. Now some of you might be thinking, if the belt is tension at the ends of the motor bells, and they're mounted at this end, does that not bend the two motors together? It does, but only a very small amount. I actually did some structural analysis on it before printing it to confirm that it will hold the strength of the belt, and the PLA can definitely hold it. The only issue that I might come across is that if the motors get too hot and the PLA warps, it will not be able to hold the strength of the belt spread apart. So that's going to be some interesting things to find out in the future, I guess. A few other things, I moved two much bigger bolts to clamp to the bike. This because, I don't know if you can see them, but the M8 nuts just sit better inside the PLA brackets. Now you may also notice that there is no battery on the bike. On the version 1 I had the battery in the back here, but the battery required to power this needs to be a lot bigger now. So I have moved the Vesks up to here. They're not mounted here anymore. This is a space for a rear rack if I want to take anything for transport. So yeah, the Vesks are in here, and in fact the batteries go in a backpack, and I have a long cable. Here which runs to my backpack. Eventually I want to get some lithium-ion batteries. I'm still saving up for those because they are quite expensive, which I'll probably mount in the down tube here, or on top of the down tube here, or on this tube here, which means I can shorten these wires a little bit. So I think that's a pretty good rundown of the bike. Actually, one other thing, you might notice there is no rear brake. Yeah, there's no rear brake because the bracket here actually touches the brake pad, the brake caliper right there. So what I really need to do is get a slightly shorter belt so I can move this down a little bit, because not having a rear brake at full speed on this thing is probably quite dangerous, especially in the wet. Just having a front brake is not a good idea in the wet on these narrow skinny tyres. Everything else is the same as the version 1 in terms of still have the Arduino chip and the twist throttle. But yeah, all I really need now is some new batteries, I think, because this thing, 50 amps each motor, drawing 100 amps is well, basically I think my batteries are crying by the end of it. So let's go get some footage of it riding. Okay, so I've got the batteries plugged in my backpack now. You can probably see the wires there. Just test the throttle. It's all spinning. Just give it a test ride. Okay, straight away, I can already feel a massive power increase. I'm only just cruising at about half throttle right now. Let's give it some power. Whoa! Right, make a left-hand turn down a quiet lane. This is so fast! Oh my god, this is so fast! I'm still not able to give it full throttle at the moment. I can feel the smaller belt slipping on the motor pulleys. Yeah, so when I give it really high throttle inputs, I can feel the smaller belt slipping. So I think I still need to print slightly larger pulleys. Yeah, I can hear the belt slipping slightly. So I'd like to thank you very much for watching this video. This is probably the version 4 or version 5 of the electric bike, the second version of the dual motor at least. And this is obviously the first video of the dual motor. As you can guess, going through all these versions has used a lot of 3D printer filament. So I'd like to thank my sponsor, 3D Prints Limited. They've been great with supplying me with all the PLA that I need to make multiple versions and modifications. As you'll probably guess, I'll be modifying these pulleys, making them slightly larger again to increase the tension on the belt. I don't know whether it's just that the belt stretches after a little while. So yeah, I'll have to do that modification soon. Also, because these projects cost so much money and also take so long, for me to do more of them more often, it would be great if you could help support me on my Patreon account, which I'll link down below. Even just $1 a month is fine, and I'll be really grateful for it. I will also be uploading the STL files from this quite soon to my Patreon account, so if you wish to have the STL files, then help me out. Thank you once again for watching. If you're new to my channel, please subscribe, and if you like the video, leave a thumbs up. Goodbye.